Good day, learners! Welcome to Math Corner's Journal Mathematics for Senior High School, Episode 3, entitled How to Evaluate Functions at Specific Values. What is function notation? The notation y is equal to f of x defines a function named f. This is read as y is a function of x. The letter x represents the input value or independent variable. The letter y, or f of x, represents the output value or dependent variable. Let's say, for example, a function n is equal to f of y gives the number of police officers n in the town in year y. What does f of 2005 is equal to 300 represent? How will you interpret the given situation about function? When we read f of 2005 is equal to 300, we see that the input year is 2005. The value for the output, the number of police officers, n is 300. Remember, n is equal to f of y. The statement f of 2005 is equal to 300 tells us that in the year 2005, there were 300 police officers in the town. Let us now proceed in evaluating functions at specific value. But how do we evaluate functions? Here are the two basic steps on how to evaluate functions. First, replace the input variable in the formula with the value provided. Second, calculate the result. Consider this example. Evaluate f of x is equal to x squared plus 3x minus 4 at x is equal to 2. By that, we have to simply substitute all the variable x with the value of 2. That means we have f of 2 is equal to 2 squared plus 3 times 2 minus 4. Then simplify. So we have f of 2 is equal to 4 plus 6 minus 4, which is equal to 6. What does it implies? This implies that for every input 2, there is an output 6. Let's take a look with the other example. Evaluate f of x is equal to x squared plus 3x minus 4 at x is equal to a. In this case, the input value is a letter, so we cannot simplify the answer any further. To continue, we have f of a is equal to a squared plus 3a minus 4. Disregard the parentheses, so we have f of a is equal to a squared plus 3a minus 4. Let's have the second example. Evaluate f of x is equal to square root of x plus 2 at x is equal to m. Replace x with the letter m, so we have f of m is equal to square root of m plus 2. Or, we have f of m is equal to square root of m plus 2. What about if we have a different case? Let's take a look with this example. Evaluate f of x is equal to x squared plus 3x minus 4 at x is equal to a plus h. In this case, with an input value of a plus h, we must use the distributive property. Replace all the variable x with a plus h, so we have f of a plus h is equal to the quantity a plus h squared plus 3 times the quantity a plus h minus 4. Expand the binomial a plus h squared, which is equal to a squared plus 2ah plus h squared. Distribute 3 to the two terms inside the parentheses, which yields to 3a plus 3h, and then copy minus 4. Since we cannot simplify any further, that means this is now the final answer. Let's have the second example. Evaluate f of x is equal to 5x squared plus 2x minus 1 at x is equal to a plus h. Replace all the variable x with a plus h, so we have f of a plus h is equal to 5 times the quantity a plus h squared plus 2 times the quantity a plus h minus 1. Expand the binomial a plus h squared, which is equal to 5 times the quantity a squared plus 2ah plus h squared. Distribute 2 to the two terms inside the parentheses, which yields to 2a plus 2h, then copy minus 1. Distribute 5 to the three terms inside the parentheses. So we have 5a squared plus 10ah plus 5h squared, then copy 2a plus 2h minus 1. In our next example, in this case, we apply the input values to the function more than once, and then perform algebraic operations on the result. Consider this example. Evaluate f of x is equal to x squared plus 3x minus 4 at f of a plus h minus f of a all over h. Previously, we already solved f of a plus h is equal to a squared plus 2ah plus h squared plus 3a plus 3h minus 4, as well as f of a is equal to a squared plus 3a minus 4. By that, we just simply substitute it to the function. So we have f of a plus h minus f of a all over h is equal to a squared plus 2ah plus h squared plus 3a plus 3h minus 4, which is our f of a plus h, minus a squared plus 3a minus 4, which is our f of a, all over h. To continue the solution of the previous example, distribute the negative sign to the terms inside the parentheses, which yields to a squared plus 2ah plus h squared plus 3a plus 3h minus 4 minus a squared minus 3a plus 4 all over h. Simplify it by combining similar terms by a manner of cancellation. So we can cancel a squared and negative a squared, positive 3a and negative 3a, negative 4 and positive 4. By that, it yields to 2ah plus h squared plus 3a all over h. Factor out h, which will become h times the quantity 2a plus h plus 3 all over h. Then simplify. Cancel both h in the numerator and in denominator. Therefore, our function is equal to 2a plus h plus 3. Now it's your turn. Let's practice. Evaluate the function f at indicated values. First, evaluate f of x is equal to 6x minus 1 over 5x plus 2 at x is equal to negative 3. Substitute all the variable x with negative 3, which yields to f of negative 3 is equal to 6 times negative 3 minus 1 over 5 times negative 3 plus 2. Then simplify. So we have f of negative 3 is equal to negative 18 minus 1 over negative 15 plus 2. Then simplify further. F of negative 3 is equal to negative 19 over negative 13. Then we have negative divide negative equals positive. Therefore, f of negative 3 is equal to 19 over 13. So we have y is equal to 19 over 13 if x is equal to negative 3. Let's have question number 2. Evaluate f of x is equal to 6x minus 1 over 5x plus 2 at x is equal to negative a. Substitute all the variable x with negative a, which yields to f of negative a is equal to 6 times negative a minus 1 over 5 times negative a plus 2. Then simplify. So we have f of negative a is equal to negative 6a minus 1 over negative 5a plus 2. Since we cannot simplify this one any further, therefore, y is equal to negative 6a minus 1 over negative 5a plus 2 if x is equal to negative a. Let's have the last question. Evaluate f of x is equal to 6x minus 1 over 5x plus 2 at x is equal to a plus h. Substitute all the variable x with a plus h, which yields to f of a plus h is equal to 6 times the quantity a plus h minus 1 over 5 times the quantity a plus h plus 2. Then simplify. So we have f of a plus h is equal to 6a plus 6h minus 1 over 5a plus 5h plus 2. Since we cannot simplify this one any further, therefore y is equal to 6a plus 6h minus 1 over 5a plus 5h plus 2 if x is equal to a plus h. Thank you for watching. I hope you learned something from the video for today. See you on my next episode. Goodbye!